to now, we've been discussing how we get from an initial set of conditions to equilibrium. Here we're going to look at what happens when we have a system that's at equilibrium and then we change something about that system. Le Châtelier's principle says if we have a system at equilibrium and something is changed, the system will react in a way to minimize the effect of the change. And there are a couple of things that we can change about our system, so let's look at those. One is concentration. If I increase the concentration, the system will shift in a way that consumes this increased amount. Okay. Conversely, if I decrease a particular component, the system's going to shift in a direction to make more of that component, to make up for the fact that I'm pulling it out of the system. When we're talking about temperature, we need to remember that the way that it changes is going to depend on whether we have an endothermic or exothermic system. Okay, so let's just remember what that means here. Alright, so if I have an endothermic situation, that means that my delta H is positive, which means that we can think of the heat added as a reactant. Okay, and it helps when you're doing these problems to kind of go ahead and just add that energy component into your balanced equation. Similarly here, if it's exothermic, remember that means our enthalpy change is negative. That means that we can think of that energy as a product. Okay. Now, the other type of thing we're looking at is changes in pressure. The first part to remember is that if we add an inert gas to our system, it does not affect the equilibrium position. Okay, inert gas, we usually think of that as meaning like a noble gas, something that doesn't react with anything, but essentially here we're talking about something that does not react with anything that's in our system. Then the other is changes in volume. Changing the volume of our system is going to change the pressure. And again, the system is going to shift in a way that's going to minimize the effects of the pressure changes. So if my pressure is, if the change increases the pressure, then the system will shift in a way to minimize that increase, which means what? Means it's going to make fewer gas molecules. Similarly, if I increase the pressure, it's going to shift in a way to make fewer gas molecules. Alright, so let's look at a specific example here. Here we have this reaction, and it is endothermic. So we have our energy on our reactant side. Alright, so here we have adding more of the bromine. Bromine is over here on the product. If I increase the amount of my bromine, it's going to shift towards making more reactants. So it will shift left so that it consumes some of that additional bromine. If we remove some of our reactant, so over here on this side, we remove that reactant, then it's going to basically shift in a way to make more of that reactant. So this one, it would also shift left. Okay, decreasing the temperature. If I decrease the temperature, all right, that's like decreasing on this side, removing energy. That's going to make it shift back towards my reactants because that's the side the energy is on. So it's going to shift left on that one. Okay, and then now increasing the container volume. And I like to kind of break this down into steps. So let's think about it. If I increase my container volume, that means my pressure is going to decrease. If the pressure is decreasing, how am I going to counteract that? I'm going to counteract that by making more gas molecules. Okay, so let's look here. We have 2 plus 1, so 3 moles of gas on the product side, and I just have 2 moles of gas on my reactant side. So it's going to shift towards the products or shift right. All right, here's another one. This one is exothermic. Okay. And so if I add N2O4, if I add more of the product, it's going to shift it in the way to consume it, which means it's going to shift left. It's going to make more reactants. If I remove NO2, remove the reactant, it's going to shift to make more. So again, it's going to shift left. If I increase the volume, pressure will decrease, and so then it needs to make more gas molecules. And so I have 1 mole of gas as a product, 2 moles of gas as a reactant, and so it's going to make more reactants, so it's going to shift left. If I decrease the temperature, decreasing the temperature means I'm removing heat from my system. It's going to act to create more heat, so it's going to shift right. And then if I add nitrogen, nitrogen is an inert gas, and we would say that is not going to result in any change in our system.